When systems on a network start experiencing connectivity issues, IT professionals go through a series of checks to identify where the problem originated. These connectivity issues can be physical, such as a network cable being unplugged, or they can be configuration issues, such as a bad router or other infrastructure setup problems. There are a seemingly infinite number of things that can cause issues, and learning to troubleshoot them takes practice and experience. One of the tools that's frequently used for identifying network-related problems, including connectivity issues, is Wireshark. Wireshark is a free and open-source network protocol analyzer for capturing network frames and packets. In this demonstration, I'll walk you through troubleshooting connectivity issues with Wireshark. I'll do this on a network segment where some clients can reach the internet and others are unable to connect to anything. Now, I should point out that this is a test environment, and the goal is to show you how to use Wireshark to identify a general network problem. Since there are thousands of potential problems that could manifest themselves in the real world, I'll only show you how to find a single problem, not every potential use of Wireshark. This means you'll need to practice and probably extrapolate when you're troubleshooting issues in a live environment. As I said before in our scenario, some users can connect to network resources and the internet without issue, and others can't connect at all. I researched all other avenues before arriving at the conclusion that I need to look at network traffic to figure out what's wrong. In other words, I've already ruled out switch and router issues. I did find that some hosts have a bad default route, pointing to an unused IP address. I'm now going to use Wireshark to see if I can find the source of the problem. On my Kali Linux box, I'll open Wireshark and have it start capturing packets. Remember that properly configured switches and routers wouldn't allow all traffic from connected devices to propagate to all ports. In this environment, I've configured the switch to allow me to see everything that's running through it. I don't need it to run for very long to perform my initial assessment. I'll just capture for 60 seconds. Now at this point, knowing that some hosts have bad default routes, and also knowing that all the systems on this network segment except one is using DHCP for IP address assignment, I have a pretty good idea of what the problem is. I'm using Wireshark to confirm that suspicion and to identify the IP address that the problem originated from. I'm going to filter the frames I've captured using the boot ptransport protocol like so. We can define filters to look for a specific protocol, as I've done here, or they can zero in on a particular host, port, or other possible variation. As you can see, a DHCP offer was made from two different sources, 10.20.30.11 and 10.20.30.2. That means that someone has a second DHCP server on this segment. I know that the official DHCP server for this network is at IP address 10.20.30.2 since I set it up that way. With Wireshark, I can highlight the line where the DHCP traffic is listed, and down below I can view the specific information found in that data. So, if I look at the offer from the other host, 10.20.30.11, I can see that the route being given as the default route is 192.168.17.1. That's the address the systems that were unable to connect defined for themselves, and we've found a problem. The host at the IP address 10.20.30.11 is running a DHCP server, and the default route is providing it's bad. That host could have been set up maliciously, or it could just be someone playing with a service they don't understand. There's much more we can do with Wireshark. Skilled use of Wireshark can help diagnose slow traffic, help with security-related network scans, and many other things. That's it for this demonstration. In this demo, I've shown you how to use Wireshark to help troubleshoot network connectivity issues.